All right, so page 24 is where you should have put your Unit 2C test review. If you did it on scrap paper or notebook paper, that's fine. Just make sure that gets put in your notebook for your notebook check, okay? I want y'all to have everything in there in the same place for when you're studying. And then today we're starting Unit 3, which is on quadratic applications and other functions. And then we're going to be starting page 25, which is quadratic applications in Desmos. So I'm going to pause and give y'all about a minute to make sure your notebook's up to date. What we're going to talk about today is how, if you're given a quadratic equation, how you can just go put the function in Desmos. Desmos will graph it for you. So do y'all know in Unit 2B, when I had you doing negative b over 2a, plugging it back in, all that stuff by hand? Yeah, some of y'all gonna hate me today because, I mean, there was a purpose for that, but Desmos will actually find the vertex and all of the features for you, okay? The reason we have to find it by hand, when you get to Math 3, part of that EOC is non-calculator. But also when you get to college, a lot of college math classes, you're not allowed to use Desmos. All right, so there is a purpose to learning this stuff by hand, but we're gonna learn how to do it in Desmos today. So the first thing we're gonna do is just write down steps for graphing in Desmos. Oh my God, I spelled graphing wrong. Steps for graphing in Desmos. Notes today are very short. We're going to do these steps, like 2 examples, and then I'm going to move on to the little note sheet I posted on Canvas. All right, so steps for graphing in Desmos. So the first thing you're going to do is go to www.desmos.com. So on the test for this unit, you will not need to click a new tab. My children that opened new tabs yesterday. I will embed Desmos in Canvas. Like I will link it in Canvas. All right. So you're going to go to desmos.com. Second thing you're going to do is click in a new box and type in the function equation. So when you're using a graphing calculator, what form do you think the equation has to be in? That's what I was afraid of. Okay, in middle school, they probably taught y'all like anytime you put something in the calculator, it's got to be in standard form, right? Which isn't wrong with the TI-83, so that's not wrong. But when you're using Desmos, you can actually put a function in any form. That's also why I like Desmos. So you don't need to convert anything. You can put it in vertex form. You can put it in factored form. You can put it in standard form, okay? So I'm just going to put any form so that y'all know this. Vertex, factored, or standard. Did any of y'all use Desmos in middle school? I'm just curious. Good, 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 good. Okay, like 4 or 5. All right, so then once you type that equation in, Desmos will graph it for you, okay? So the only other thing we're gonna have to do is click on parts of the graph to figure out the features. So your third and final step is to click on the points on the graph to find the specific features asked for. And that's it for steps. I'm going to pause and let y'all finish recording. All right, so example 1, copy down this equation. We're going to find the max or min value, which y'all do know how to do by hand, I hope. How would you do this by hand? For extra credit, 2 points. Not factor it, that's for the roots. The max or min is the vertex. You're right, it's the vertex. So how do you find the vertex if you were finding it by hand?
You will find the
Negative B over A.
Yeah, negative. I heard x equals, I heard find the axis of symmetry, which is negative b over 2a. That'll give you the x. And then what do you do with that to find the y value?
plug it in.
Plug the X
Plug
in.
it in. Good job, y'all. You 3, 4, 2 points on your test. Good job. So we don't need to do that though, because I'm telling you, you can use Desmos. Wow, how nice of me. So what you're gonna do y'all all have this down so I can switch my screen? All right, here we go. You're gonna go to the axis of symmetry is the x. I don't know if you were asking me, but I heard you, so I'm gonna answer. Desmos.com, hit graphing calculator. Again, this will work on a phone, tablet, computer, anything. And the cool thing about Desmos is you've got the whole screen. It's big. It's also touch screen and it color codes. So in this first new box, you're going to type in the equation. So it was y equals negative x squared plus 2x plus 1. I do want y'all to do it with me so you can practice clicking on the correct things. People at home, I would recommend doing it on your phone so you don't have to close your Zoom tab. All right, and the first thing I asked you for, because I think most of us have it typed in, is the max or min value. So first of all, look at the nice graph that Desmos graphed for you. Does this have a max or a min? A max, and we know the max is at the top, the vertex. So look, it gives you the ordered pair. Click on it. What is the maximum value? 2. The max value is the value that it will reach, aka the y. Remember, anytime I ask you for a value, I want the y of the ordered pair. If I ask you when or where it occurs, I want the x. Good, Jaden. So do y'all agree that the max value is 2? People at home?
Yes.
Okay, I'm gonna write that down then. Max value equals 2. All right, so then the next thing I asked you for was the axis of symmetry. So when we were in Unit 2B, we learned the axis of symmetry was the imaginary line. So are you gonna be able to see it? No, it's imaginary. But if you think about the line that would go right through the middle of this, right through the vertex, where is it gonna cross at? X equals what? X
1.
equals 1. Good, because the x value is 1. So look, I'm going to draw it up here so y'all can see. You do just put x equals 1. It's a vertical line. So remember, we talked about that'll always be x equals. And it goes right through 1. You could do that. Very good, Henry. So look, Henry said to check yourself, you can go below it and type in x equals 1. Y'all see how Desmos then drew it for you? Very good. That's a good way to check yourself. Extra credit. Good job. Any questions on how the axis of symmetry is x equals 1? All right. I didn't think so. I'm just making sure though. Okay. So then the third thing I asked y'all for were the roots or the solutions, right? All right. Where do we find the roots? The x-axis. Very good. So if you click on your graph, make sure I'm on my mouse. Do you see once I clicked on the graph, it highlighted it? I want y'all to see this again. If you can't see the points, click on the graph. It'll put them all there for you. Do you see how it gives me the 2 x-intercepts? So this one, they're irrational because this does not factor. So instead of doing quadratic formula or completing the square, you can use Desmos. Henry's pissed. He's like, why did we even learn those then? I could read it on your face. You need to know this for math 3, okay? But you can check yourself in Desmos. Sound cool, right? So your x-intercepts, do y'all agree it's negative 0.414 comma 0 and then 2.414 comma 0? Do not round it. That's a great question. Whatever numbers you see in Desmos, I need you to write those. We'll talk about rounding if we have to, okay? If you are doing an assignment in Delta Math, they always tell you how to round. So I'm gonna write these down and then I'm gonna switch my screen so y'all can see the form I wrote them all in. Do we think we'll be able to find like the max or min, the vertex, the axis of symmetry, and the zeros though from Desmos? People at home, are y'all good?
Yeah.
All right. Okay, I'm gonna switch back. So these are the answers you should have gotten. So I'm gonna pause and make sure we're all okay, and then we'll do another one. All right, so example 2, we're gonna deal with this quadratic equation. What form is this equation in? Vertex form, good, Jake. So vertex form doesn't matter. Do you need to convert it to put it in Desmos? No, Desmos will deal with any forms. Now, I do want to talk about the f of x piece right here. So people at home, do y'all have this written down? We're going to find the y-intercept, domain range, and our intervals. Anybody need more time? Okay, I'm going to switch then if y'all are good. All right, so let's go put it in. So I'm just going to exit out these boxes. Sometimes we're going to see if it'll work this time. Yeah. So do y'all see how Desmos does not like the f of x? Did it work on y'all's? It worked on yours? Are you using the Desmos app? Or the website? Okay. Oh, there we go. It's actually working. Sometimes it's finicky if you use f of x. So what did you say you just used? A y. Remember, f of x means the same thing as y. They're both the output, okay? So you can put f of x. I'm also fine if you put y. So I'm going to type it in. Make sure you do put the parentheses in the right spot. But do y'all see how it graphed it for us? And then if you ever can't see your graph, you can move it around. You can zoom in and out. Let me move this so y'all can see there's an in and out. If you hit the home, it takes you back to like the standard centered screen. Okay? Lots of stuff you can do. So what's the first thing I asked y'all for? The y-intercept. Where do we find the y-intercept? Where it crosses the y-axis. Good. So y'all, again, click your graph. It'll pop up with all the needed points. So if I click right here on the y-axis, the y-intercept is 0,6.5. Everybody okay with how that's the y-intercept? So again, you have to know where to find these, but Desmos will give you the actual numbers for a lot of them. Is everybody good? Okay. I know it doesn't ask for the vertex and it doesn't ask for the axis of symmetry, but why do y'all think I just put those in? What did they ask for where we might need those numbers? Domain range and intervals. If you know that max or min point, that vertex, and where the axis of symmetry is, that's going to help you with your domain range and intervals. So I'm going to make sure I know where these are at, okay? All right, I'm going to write this stuff on the screen to make sure everybody's good and they're with me. So domain is the smallest x to the largest x. This parabola, if you zoom out, I just want y'all to watch so y'all believe me. It keeps going left and right forever and ever. The only reason it looks like it's getting skinnier is because I'm zooming out. So it's getting farther away, okay? So if it goes to the left and the right forever, what's the domain? Yes, it doesn't change for a parabola. Negative infinity, positive infinity. It will always be that. What about the range? Very good, Henry. All right, y'all listen. Smallest y value is 2. Start at the bottom of your graph. It starts at 2. So what do I need with the 2? A bracket. And then it opens up. So what should it open up to? Infinity, positive infinity, right? Because it's opening up. You don't have to put the plus sign. If you just put infinity, that means positive infinity. Good. I'm going to pause because some people look a little puzzled. Range is always bottom to top, smallest y to biggest y. So the smallest value on this graph that is a y value is 2, and it goes up. People at home, are y'all good?
Yeah.
Yes,
All right. Okay. Awesome. Okay. Which side is the graph increasing on? We're going to do our increase first. Which side? Good. The right. So listen, if it increases on the right side, we know it starts where? Good. Do not tell me 2. That's wrong. It starts at 3. Where does it start? The X. So it starts increasing at 3 at that wall, and it increases all the way on the right to what? Good, y'all. Positive infinity. Very good. I'm excited y'all get this. The other honors math 2 teachers told me they weren't sure their kids got it. Which side is it decreasing on? The left, so it's going to start at negative infinity, and it goes until it hits the wall at 3. Very good. So do we feel like we could do domain range increase, decrease? People at home, y'all are quiet. How do y'all feel?
Good.
Good? Order this. If you are at home, I posted the worksheet, the little, it's like half a sheet that we're using for the rest of the notes. So you can either print it, watch this later to fill it out, or if you don't have access to a printer, that's totally fine. I'll tell you which parts you need to write down, okay? But it's not a lot. So my people who have this in class, you don't really need your notebook anymore. You can move it out the way. You can put this over it, whatever. And before we even get into this picture, we're going to do a real world example. And I'm going to use one of my basketball players. I don't know which one I want to use. Connor looked up like, please don't use me. Jordan, that leaves you. That leaves you. All right, everybody pay attention. You do not have to write this. I'm giving you a real world scenario, okay? I'm going to draw. Y'all know I'm not an artist, so no making fun of me, capiche? If I make Jordan's head big, it's just because I'm not a good drawer. I'm not trying to make fun of him. No one try to roast him, because then I'm going to roast you. Got it? All right. All right, Jordan. Oh, let me make your legs longer. All right, this boy balling. Is everybody watching? Y'all, whoever has art, y'all please go tell Mr. Varney and Miss Story that I drew in class today, because they like to make fun of me. Jordan's balling, okay? He got fouled in his game, and he gets to shoot free throws. Chris looked excited. He was like, okay, we finally talk about some real life stuff. When Jordan shoots a basketball, what shape is the ball going to make? Show me with your hands. Fantastic. I just showed you a parabola. This is why Miss Poole loves parabola so much. You kick a soccer ball, parabola. You throw a baseball, parabola. You hit a baseball, parabola. You throw a football, kick a football, parabola. Hit a tennis ball, parabola. Shoot a basketball, parabola. Because what goes up has to come back down. Extra credit. What scientist discovered that? Nope. Yes, good. Newton's law of gravity. Very good. So listen, you did. Both of you said it. So listen, when I shoot my pen right now, I hope we're all looking. When I shoot my pen, what goes up comes down. Its path makes a parabola. Over spring break, you will have an extra credit project where you're going to go shoot a ball or kick a ball or do something. Oh my God, that scared me. I saw it coming at my eye and I was still talking. You're going to do something, and if you record its path, I'll give you all the details. It's an extra credit project. It'll get rid of your lowest quiz grade, okay? Maybe your lowest 2 quiz grades. Depends on how nice I'm feeling. It's an easy project, that. And it helps you see how parabolas are used in the real world, all right? So when Jordan shoots this basketball, do we agree it's going to make a U shape? Yes. All right, now let's use our brains, because last year I had a kid draw it like this. Let me show y'all what this baby did. Bless him. Y'all know Carson Turner? Evan, I know you do. Carson drew it like this. I said, Carson, are you dunking on a little tight skull? Like, Jordan is not 10 feet tall, so the ball should go a lot higher than he is, correct? So maybe like this. And then let's say he swishes it, nothing but net, and it lands. Y'all following me? You don't want me to draw the ball. It's going to be really bad. So just, we're good with the dashes. Let's say it takes the ball 3 seconds. That sounds about right. 3 seconds to land back on the ground. Did everybody hear me say that? Is the domain of this real world problem going to be negative infinity to positive infinity? No. As soon as Jordan shoots that ball, when it's still in his hands, that's 0 seconds because he hasn't shot it yet, right? As soon as it comes out, we start timing it. And then as soon as it hits the ground, y'all, it's going to stop. Yes, it'll bounce. Okay, whatever. It does not go through the ground. Do we all understand that? When we're talking about real world problems, what quadrant do the graphs have to be in? Okay, which is what? Yes, which is what quadrant? Quadrant
Number
1.
one.
Very good. People at home, do y'all hear this? Y'all are with me, right?
Yes, ma'am.
When you're dealing with real world problems, you cannot have negative x values because that would be negative time. Do we know how to go backwards in time? No, that's called time travel. I don't think it's a real thing. We do not know how to do that, smart aleck. You can't have negative x because that would be time traveling. You also can't have negative y's unless below sea level. I like it. Or like, you know how when you're doing, is it shot put? Doesn't the ball like get into the ground sometimes? If you like real strong and if it's real heavy, right? Okay, I didn't make that up. If it goes below ground level, then the y could be negative, but that doesn't usually happen unless you're talking about like a submarine, scuba diving, shot put. Do we understand? So where are most of these going to be? In what quadrant? Quadrant 1 on your extra credit project over spring break. If somebody puts negative infinity to positive infinity, I'm not even grading it. You done lost my interest. Do we understand? I'm letting you know. These should be in quadrant 1. Is everybody okay with that? That was the whole purpose of me drawing Jordan. Jordan, let me give you a little twist. No, I'm not even going to try. He's like, don't do it. Please don't do it. All right. So this is why I wanted to talk about this. If you are at home, you have this little picture, okay? What I want you to draw at home is a coordinate plane. And I just want you to draw this graph on the coordinate plane. So you can start it here because we said it should be in quadrant 1. Draw it going up, and then when it hits the ground. And then we all just talked about how this should always be 99% of the time, unless we're talking about a submarine, in quadrant 1. So if you are copying this from home, I do not need you to copy down all these text boxes. That's too much work, okay? I just want you to follow along with me before we do this example so y'all are looking in the right spot. If I ask you, let's say we're talking about tennis. You play tennis. We'll talk about tennis. Let's say we're talking about tennis, and I ask you for where Henry's tennis ball bounces in bounds. Where would that be on this graph? Talk to me. Which point? 1, 2, or 3? 3. If you tell me 1, I'm going to be pissed off. That's not on the ground. Do we understand? I'm just making sure I have kids every year find the wrong point. If I ask you when something hits the ground, that's the x-intercept down here. If you are at home, you may want to write that. People in class, you may want to write it. It depends if you think you're going to remember it or not. If you see them ask for when something hits the ground, that's the x-intercept. If they ask you for the initial height, so if I'm asking at what height did the tennis ball hit Henry's racket, are you proud of me right now making up this real world example on the fly? I'm doing pretty good. At what height did the tennis ball hit his racket? Which point would that be at? 1, 2, or 3? 1. Very good, Jaden. So what's that? Why did I write 1? Because I'm crazy. That's the y-intercept. If they ask for the initial height or when it contacted the racket or when the ball left Jordan's hand for his free throw, that is the y-intercept. So what do you think they're asking for when we use this second point, the vertex? The maximum, or in some cases, the minimum if it was a min. Good. So the vertex, let me not write that. The max/min, if they ask something about a max or min, we're going to need to look at the vertex. So if you are at home copying, that's what I need you to write down. And then in terms of these examples, my people at home, you can just write down the answers we get. I'm not going to make you write out the word problem, okay? I'm going to pause and make sure we're all good. So we're going to do example 1 off the worksheet. So this is what I want y'all to look at. It says a football is kicked into the air. Its height is given by this equation right here. So I'm going to underline it for y'all. Where can we go put this quadratic equation? Into Desmos. Now listen to me very carefully. Desmos graphs on a coordinate plane. What variables do we use on a coordinate plane? X and Y. You can't go put H's and T's into Desmos. Did everybody hear me say that? I don't think it'll work. If it worked on your, did it work? I didn't think so. I don't think it works. Huh? It worked on yours? I don't. All right. Anyways, don't use H's and T's because on a lot of y'all's, I don't think it's going to work. Yes. Thank you, Chris. It don't work. So I need you to use X's and Y's. So we're going to go into Desmos and we're going to type in Y equals -4.9x squared plus 24.5x plus 1. So I'm using X's and Y's. Oh, Desmos knows me so well, it color-coded it with what color I was using. That's so cool. It's the little things. Do you see how it graphed it for us? Very nice, right? This equation had decimals in it, so having to find stuff by hand would be really annoying because there's decimals. So I'm going to zoom out a little bit so we can see the whole thing. Maybe. Come on, little guy. Oh, there we go. Perfect. And I'm going to click on it so it shows up with all my points. So let's read the questions it's asking us for. How high is the ball after 1 second? How could you figure this out? Go to where, I love that answer. Go to where x equals 1. What were you going to say, Jake? Same thing? What were you going to say? Yours is not working. I'll come look at it in 1 second. Make sure you typed it in right. Not trying to be funny. Okay. Give me a second. People at home, how else could we look at the height at 1 second? Hello, there's more than one way to do this. How else could you find the height at 1 second? Okay, you could type in, I'm hearing different things, which is good. That's what I wanted to hear. You could type in x equals 1. And do you see how it graphed it for us? Does everybody see how it showed you x equals 1 in black? I'm going to zoom in so you can see it. Holy cow, that's not what I wanted. Here we go. This line right here, I'm going to do it again so you see. Everybody watch for the black line to pop up. And now it's red. Boom. That point where they cross is where that parabola is at 1 second. So how high is the ball after 1 second? 20.6 what? Good, I'm being very picky, feet. Very good, 20.6. Now, did it actually tell us feet, or are y'all just assuming it's feet? Okay, let's not assume. Let's say 20.6 units. Because since we're talking about a football, technically they could be measuring in yards or meters or inches. If you only kick a football 20.6 inches, your old teacher kicks it higher than you. I used to be able to kick a 15-yard field goal. I don't know who kicking 15-yard ones, but I mean, still, that's pretty impressive for a girl. 20.6 units. Now, let me show you another way you could do this. I was hoping somebody would say this. I'm going to get rid of that really quick. You can also, once you have this graphed, y'all, you can just click and drag on the graph. Did y'all know that? You were doing that? So look, you could click and drag it till it hits 1. It is hard. Boom, but I just did it. 20.6. Huh? Is that how you did it? Cool. Yeah, you can click and drag till you get to 1, or you can do what some of your other classmates did and type in x equals 1. Either way. Are we okay with how to find how high the ball is after 1 second? Y'all feel like you could do that? All right, I feel like some of y'all are moving on. Find the maximum height of the ball. So maximum, I'm gonna scroll up, click the top. Which of those numbers is the maximum height? 31, good, 31.625. It is not the X, it's the Y value. Remember that X is the time. When we're talking about real world problems, X is like 99% of the time the time, okay? So the max height is 31.625 units. Man, writing actual words with this pen is hard. 31.625. All right, people at home, are y'all good with the second part?
Yeah.
Yes,
Okay.
ma'am.
All right, let's keep going. How long does it take to reach the maximum height? 2.5 seconds. It gave you the units for time. Good. It should have given it to you for height too. She just forgot to put it up there. 2.5 seconds. Because that's the X value of the maximum. Do we understand the difference between the X and the Y? X is time, Y is the height. We're good? All right, so then the last one, when does the ball hit the ground? So let's go back to our graph. Okay, how do you get that number? Tell me what you did. Very good. Good. On the right side? Perfect. He clicked on the x-intercept on the right side. Now listen to me very carefully. If you click on the x-intercept over here, I'm going to make fun of you. It's out of love. How's the ball going to hit the ground at negative 0.04 seconds? That doesn't make any sense. When you kick it, it's going to go up and come back down. So we want the one on the right-hand side, okay? So the x-intercept, how long it takes to hit the ground, is 5.04 what? Very good, Evan, seconds. 5.04 seconds. If you kick it backwards, the time is still going positive. You can't kick it backwards in time. You're going to have it hit the ground and then come back and hit your foot. I would love to know how you do that. Did anybody do this in Math 1? You did. Yes. He was like, I don't know. I guess I did since you said it. Did you do it in Math 1? Okay, hang on. I'll take questions in 1 second. Anybody at home, did y'all do this in Math 1? Because you were supposed to.
I think so.
Okay. Do y'all need me to do another one, or you feel like you could do these? You've got 16 minutes. I really feel like you can do them. No, you got to do a delta math. You wish you just had 2 problems. No, you do not need to do the last 2. Nope. All right, so now I'm going to pause recording and I'm going to take questions if you have them. If not, you're good to